Mayday, Mayday, American 587 Heavy, we're going down! The frantic voice of First Officer Sten Molen crackled through the radio waves on that clear November morning in 2001, just 2 months after the world had witnessed the unthinkable horror of September 11th. The Airbus A300-600 was climbing through 3,000 feet above Queens, New York, when everything went catastrophically wrong in a matter of seconds. What happened next would become one of the most devastating and mysterious aviation disasters in American history, claiming 265 lives and forever changing how we understand the delicate dance between pilot training, aircraft design, and the unforgiving laws of physics that govern flight. The morning of November 12, 2001, dawned crisp and clear over John F. Kennedy International Airport, with visibility extending for miles in every direction and gentle winds that seemed perfect for flying. American Airlines Flight 587 sat at Gate 22, a magnificent Airbus A300-600 that had served faithfully for over 11 years across millions of miles and thousands of flights. At 199 feet long with a wingspan stretching 147 feet, this twin-engine wide-body aircraft was a workhorse of international aviation, designed to carry passengers safely across oceans and continents, with the reliability that had made commercial aviation the safest form of travel. The registration N14053 gleamed in the morning sun as ground crews performed their final preparations with the methodical precision that defines modern aviation operations. Captain Edward States, 42 years old, with over 9,000 flight hours under his belt, conducted his pre-flight inspection with the thoroughness that had earned him respect throughout American Airlines and beyond. His father had been a pilot for Eastern Airlines, and aviation was truly in his blood, flowing through generations of his family who had dedicated their lives to the science and art of flight. States had recently completed his training on the A300 after transitioning from the Boeing 727, a process that required hundreds of hours of study, simulator time, and check rides to ensure complete familiarity with every system, procedure, and emergency scenario. His colleagues described him as thorough, professional, and safety-conscious to a fault, the kind of pilot who would spend extra time studying aircraft manuals and reviewing procedures even after decades of experience. First Officer Sten Molen, 34, was equally experienced with nearly 6,000 flight hours and extensive training on the complex Airbus systems that represented the cutting edge of aviation technology. The Swedish-born pilot had immigrated to the United States to pursue his aviation dreams, leaving behind family and friends to build a career in the demanding but rewarding world of commercial aviation. He had worked his way up through regional airlines, charter operations, and corporate flying before earning his position with American Airlines, one of the most prestigious carriers in the world. His logbook told the story of a dedicated professional who had flown everything from small single-engine aircraft to sophisticated jets, accumulating experience in all weather conditions and airports across the globe. In the cabin behind them, 8 experienced flight attendants prepared for what should have been a routine flight to Santo Domingo, Dominican Republic. These seasoned professionals, led by purser Karen Martin, who had over 15 years of experience with American Airlines, methodically checked safety equipment, reviewed passenger manifests, and prepared the cabin for departure with the efficiency that comes from thousands of similar preparations. They greeted early boarding passengers with warm smiles and professional courtesy, helping families find their seats, assisting elderly travelers with their carry-on luggage, and ensuring that every passenger felt welcome and secure as they prepared for their journey to the Caribbean. The passenger manifest showed 260 souls on board, including many Dominican families returning home for the holidays, business travelers conducting important meetings, and tourists seeking the warm Caribbean sunshine and pristine beaches that made the Dominican Republic such a popular destination. Among them were children excited about seeing grandparents they had not visited in months, parents carrying carefully wrapped gifts for loved ones, and individuals starting new chapters in their lives with hope and anticipation. Each passenger had their own story, their own dreams, their own reasons for making this journey, and their own loved ones waiting for their safe arrival at Las Americas International Airport in Santo Domingo. Maria Santos, 34, was traveling with her 2 young children to visit her mother who had been ill for several months. She had saved for over a year to afford the tickets, working double shifts at her job in Manhattan while caring for her family and dreaming of the reunion that awaited them in the Dominican Republic. Her children, ages 6 and 8, pressed their faces against the windows as the aircraft prepared for departure, marveling at the size of other airplanes and the busy activity of the airport ground crews. Their excitement was infectious, spreading to other passengers who smiled at their wonder and remembered their own first flights and the magic of aviation that never quite fades completely. The aircraft itself told a remarkable story of modern aviation engineering and the relentless pursuit of safety that drives every aspect of commercial aircraft design. The Airbus A300 was revolutionary when it first flew in 1972, being the world's first twin-aisle, twin-engine wide-body airliner, and representing a fundamental shift in aviation philosophy toward more efficient, reliable, and economical operations. This particular aircraft, delivered to American Airlines in 1988 during the height of the aviation boom, had accumulated over 37,000 flight hours across thousands of safe journeys, carrying hundreds of thousands of passengers to destinations around the world without incident. The maintenance record showed meticulous care and attention, with every required inspection completed on schedule, every component replaced according to manufacturer specifications, and every system tested to ensure perfect operation. The two General Electric CF6 ATC-2 engines, each capable of producing 61,500 pounds of thrust and representing decades of engineering advancement, had been meticulously maintained according to strict regulatory standards that left nothing to chance. Every blade in the massive turbine sections had been inspected using advanced techniques including X-ray analysis and magnetic particle inspection to detect even the smallest flaws that might compromise performance or safety. The engines had accumulated thousands of hours of operation without significant problems, testament to both their robust design and the exceptional maintenance standards maintained by American Airlines technical crews, who took pride in keeping their fleet in perfect condition. Every system had been checked, every component inspected, every procedure followed to the letter according to maintenance manuals that contained the accumulated wisdom of decades of aviation experience and millions of hours of safe operations. At 9:13 a.m., Captain States received clearance for pushback from the gate, beginning the familiar ballet of departure that plays out thousands of times daily at airports around the world. The powerful pushback tug engaged with precision as ground crews guided the massive aircraft away from the terminal, their hand signals and radio communications coordinating every movement with practiced efficiency. Passengers gazed out windows at the bustling airport activity below, watching ground crews scurry around other aircraft, baggage carts racing to make connections, and the endless stream of arriving and departing flights that makes JFK one of the busiest airports in the world. Many passengers were making final phone calls to loved ones, sharing excitement about their trip, or making last-minute arrangements, their voices blending into the quiet hum of conversation that fills aircraft cabins before departure. The engines spooled up with their characteristic whine as States began the taxi toward runway 31L, the massive turbines drawing in thousands of cubic feet of air per second and compressing it to create the thrust that would soon lift them into the sky. Following the precise ground control instructions that would guide them through the complex maze of taxiways, ramps, and holding areas, States maneuvered the aircraft with the skill that comes from years of experience navigating the challenging environment of major airports. The Airbus responded smoothly to his inputs, its advanced flight control systems providing feedback and assistance, while maintaining the direct connection between pilot and machine that defines the art of flying. The air traffic control tower was busier than usual that morning, with controllers managing the complex choreography of arrivals and departures at one of the world's busiest airports, with the precision and professionalism that keeps the global aviation system moving safely and efficiently. Dozens of aircraft from airlines around the world were moving through the controlled airspace, each following precisely planned routes and procedures that had been developed over decades to maximize safety and efficiency. American 587 was cleared to taxi behind Japan Airlines Flight 47, a massive Boeing 747-400 bound for Tokyo with a full load of passengers and cargo. The beautiful Japanese jumbo jet, weighing nearly 400,000 pounds when fully loaded with fuel, passengers, and freight, would unknowingly play a crucial role in the tragedy about to unfold. its massive size and weight creating aerodynamic disturbances that would prove deadly for the aircraft following behind. Wake turbulence, the invisible rivers of disturbed air that trail behind large aircraft like oceanic currents in the sky, would become the first domino in a catastrophic chain of events that no one could have predicted or prevented using the knowledge and procedures available at that time. These powerful vortices, created by the pressure differential between the upper and lower surfaces of aircraft wings, are a fundamental characteristic of flight that affects every aircraft from small trainers to massive cargo planes. At 9:14 a.m., Captain States lined up Flight 587 on runway 31L, directly behind the departing JAL 747, following standard procedures that had been refined over decades of safe operations at major airports around the world. The sight of the massive Boeing 747 ahead of them was both impressive and routine, as these encounters between different aircraft types happened thousands of times daily without incident. Standard separation procedures called for a 2-minute interval between departing aircraft, a safety margin designed to allow wake turbulence to dissipate before the following aircraft encountered it. But this separation was based on average conditions and typical aircraft responses, rather than the extreme scenario about to unfold. Wake turbulence from a 747 is particularly severe due to the aircraft's enormous size and weight, creating powerful vortices that can persist for several minutes and extend for miles behind the aircraft, with an intensity that can overwhelm smaller aircraft or those with specific design characteristics. These invisible tornadoes of air, spinning at hundreds of revolutions per minute with energy that could power a small city, pose a significant hazard to any aircraft that encounters them, especially during the critical phases of takeoff and initial climb, when aircraft are at their most vulnerable and pilots have the least time to react to unexpected disturbances. The physics of wake turbulence are complex and not fully understood even today, involving the interaction of multiple factors including aircraft weight, wing design, atmospheric conditions, and the specific flight path that determines how these invisible rivers of disturbed air move and dissipate over time. The Boeing 747 thundered down the runway at 9:11 a.m., its 4 massive Pratt & Whitney engines generating nearly 250,000 pounds of combined thrust as it lifted gracefully into the morning sky with the majesty that has made the 747 an icon of aviation for over 5 decades. Behind it, invisible but deadly, twin vortices began their predictable spiral toward the ground, following the laws of fluid dynamics with mathematical precision that would have been beautiful to observe if not for their lethal potential. These vortices, each containing energy equivalent to a small tornado, began their characteristic descent and lateral movement according to atmospheric conditions, wind patterns, and the complex aerodynamic equations that govern how disturbed air moves through the atmosphere. Captain States and First Officer Moline would have been well aware of wake turbulence procedures, having trained extensively on the phenomenon during their careers and received regular updates on best practices and safety procedures. However, what they could not know was that their aircraft was about to encounter one of the most severe wake turbulence events ever recorded in commercial aviation, a perfect storm of conditions that would test their aircraft and their skills beyond any scenario they had trained for in the simulator or experienced in their combined decades of flying. The training they had received, while comprehensive and based on the best available knowledge, was about to prove inadequate for the extreme conditions they were about to face. At exactly 9:14:28 a.m., American Airlines Flight 587 began its takeoff roll under perfect weather conditions that seemed to promise a routine departure. Captain States advanced the throttles with the smooth, deliberate motion of an experienced pilot as the twin General Electric engines wound up to full power, their massive turbine sections spinning at thousands of revolutions per minute and pushing the 253,000-pound aircraft forward with tremendous force. The Airbus accelerated smoothly down the 14,572-foot runway, its advanced flight management systems continuously monitoring every parameter from engine performance to wheel speed to atmospheric conditions as airspeed built steadily toward the critical rotation speed that would allow them to leave the ground and enter their natural element. The runway markers flashed past with increasing frequency as the aircraft gained speed, the white centerline stretching ahead toward the point where Earth would give way to sky and the ancient dream of flight would once again become reality. At 160 knots, States gently pulled back on the side stick with the practiced touch that separates skilled pilots from mere operators, lifting the nose as the aircraft transitioned from ground effect to free flight in that magical moment when tons of metal and hundreds of human souls defy gravity through the miracle of aerodynamic lift. The main landing gear lifted clear of the runway as Flight 587 climbed through 500 feet, following the standard noise abatement procedure that would take them over Jamaica Bay before turning southwest toward the Caribbean and their destination in the Dominican Republic. Everything appeared normal in those first precious seconds of flight, with all systems functioning perfectly and the aircraft responding predictably to control inputs. The engines were performing flawlessly, producing exactly the thrust required for a safe departure. All systems showed green indicators on the sophisticated glass cockpit displays, and the aircraft was responding predictably to control inputs with the precision that modern fly-by-wire technology provides. Captain States and First Officer Moline had no way of knowing they were flying directly into the wake vortices left by the Japan Airlines 747, invisible rivers of violently disturbed air that existed in the same three-dimensional space they were about to occupy. These deadly currents of disrupted atmosphere, moving and evolving according to complex aerodynamic principles, would soon test their aircraft and their skills beyond any scenario they had trained for in thousands of hours of simulator instruction and decades of real-world flying experience. The wake vortices, invisible to radar and impossible to detect visually, were following their predictable path according to the laws of physics, descending slowly and spreading laterally as atmospheric conditions and wind patterns influenced their movement through the sky. At 9:15:36 a.m., just 68 seconds after takeoff and climbing through 1,700 feet altitude with all systems normal, Flight 587 encountered the first wake vortex with devastating suddenness. The Airbus suddenly lurched violently to the left as the invisible tornado of air grabbed the aircraft like a giant fist, rolling it nearly 18 degrees before the pilots could react to the unexpected disturbance. In the cockpit, both pilots felt the violent motion as their aircraft was thrown around by aerodynamic forces completely beyond their control or previous experience. The smooth flight instantly transformed into a terrifying battle against invisible enemies that threatened to tear their aircraft apart. The stick shaker activated immediately, its urgent rattling warning of an impending stall as the wake turbulence disrupted the smooth airflow over the wings and threatened to rob the aircraft of the lift that kept it airborne. Captain States, responding to his training and instincts developed over thousands of hours of flying different aircraft types, applied right rudder to counteract the aircraft's violent tendency to roll left and maintain control of his aircraft and the precious lives entrusted to his care. However, the Airbus A300 had a particularly sensitive rudder system that amplified pilot inputs in ways that differed significantly from other aircraft he had flown, and the control inputs that might have been appropriate for the Boeing 727 he had previously commanded were potentially dangerous on this advanced European-designed aircraft, with its different flight control philosophy and response characteristics. The wake turbulence encounter lasted only seconds, but it set in motion a sequence of pilot inputs and aircraft responses that would prove catastrophic, creating a deadly interaction between human reactions, aircraft design, and aerodynamic forces that no one fully understood at the time. As Flight 587 rolled back to wings level through the skilled efforts of both pilots working together to regain control, it encountered the second wake vortex just seconds later, this one spinning in the opposite direction with equal violence and unpredictability. Again, the aircraft lurched violently, this time to the right with even greater force, and again Captain States applied corrective rudder inputs in a desperate attempt to maintain control and protect his passengers from the invisible forces that were attacking his aircraft. The alternating nature of the wake vortex encounters created a particularly dangerous situation, with each violent motion requiring opposite control inputs that stressed the aircraft structure in ways that the original designers had never anticipated or tested. What neither pilot fully understood in those critical moments was that their aircraft's vertical stabilizer, the large tail fin that provides directional stability and control, was being subjected to alternating loads far beyond its design limits. The massive composite structure, standing 27 feet tall and engineered to withstand the most extreme conditions anticipated during the aircraft's design phase, was experiencing forces that exceeded even the most pessimistic engineering calculations. The Airbus A300 vertical stabilizer was constructed primarily of carbon fiber composite materials, revolutionary technology that provided exceptional strength while reducing weight compared to traditional aluminum construction. This advanced material represented the cutting edge of aerospace engineering, offering advantages in weight, corrosion resistance, and manufacturing efficiency that made it the material of choice for modern aircraft structures. However, composite materials behave fundamentally differently than traditional aluminum under extreme loads, exhibiting characteristics that were not fully understood by the aviation community at the time. Where aluminum might bend and deform gradually under increasing loads, providing visible warning of impending failure through creaking, bending, or other obvious signs of distress, composites can maintain their structural integrity and full strength right up to the precise moment of catastrophic failure. The alternating rudder inputs, combined with the extreme aerodynamic loads imposed by the wake turbulence encounters, were creating a deadly resonance in the vertical stabilizer structure that no one in the cockpit could detect or anticipate. The composite materials were absorbing energy with each load cycle, gradually approaching their ultimate failure point without any external indication that disaster was imminent. The loads were building toward a critical threshold where the molecular bonds holding the composite fibers together would suddenly and catastrophically fail, leading to complete structural separation. At 9:58 a.m., just 22 seconds after the first wake turbulence encounter and 90 seconds after a perfectly normal takeoff, the unthinkable happened with the suddenness that characterizes catastrophic structural failure. With a sound like thunder that passengers later described as the loudest noise they had ever heard, the entire vertical stabilizer separated from the aircraft at an altitude of 2,900 feet above the densely populated neighborhoods of Queens. The massive tail section, weighing nearly 7,000 pounds and standing 27 feet tall, broke away from the fuselage just forward of the horizontal stabilizer attachment point in a failure so complete and sudden that it left no possibility of recovery or continued flight. The failure was catastrophic and instantaneous, removing the aircraft's primary means of directional control and stability in a single moment that transformed a controllable aircraft into an unguided projectile subject only to the merciless laws of gravity and aerodynamics. In the cockpit, Captain States and First Officer Moline suddenly found themselves attempting to fly an aircraft that was aerodynamically unstable and essentially uncontrollable, though they did not yet understand the full magnitude of the structural failure that had occurred behind them. Without the vertical stabilizer providing its crucial stabilizing influence, Flight 587 began an immediate and unrecoverable departure from controlled flight, the laws of physics taking over from human skill and technology in determining the aircraft's fate. The aircraft yawed violently to the left as the asymmetric forces took control, rolling inverted as it entered a flat spin that would prove impossible to recover from at such low altitude and with such massive structural damage. The sophisticated flight control systems, designed to help pilots maintain control under normal circumstances, were powerless against the fundamental aerodynamic instability created by the loss of the vertical stabilizer. The cockpit voice recorder captured the horror and confusion of those final moments as both pilots struggled desperately to regain control of their crippled aircraft, not yet understanding that their tail had completely separated and that their situation was hopeless. The sounds recorded on the CVR revealed the professionalism and dedication of both pilots as they continued to fight for control even when faced with an impossible situation, their training and instincts driving them to exhaust every possibility for saving their aircraft and passengers. "Holy expletive!" First Officer Moline exclaimed, as the aircraft's violent motions threw both pilots against their restraints with forces that threatened to render them unconscious, the sudden transition from normal flight to chaos happening so quickly that the human mind could barely process what was occurring. The stick shaker continued its urgent warning as multiple aircraft systems began failing in cascade fashion, warning lights and alarms adding to the confusion as the aircraft's computers tried to make sense of sensor inputs that no longer corresponded to any known flight regime or recoverable situation. Captain States pulled back hard on the side stick, trying desperately to arrest the aircraft's accelerating descent toward the ground below, but without the vertical stabilizer, their control inputs were largely ineffective against the massive aerodynamic forces that had taken control of their aircraft. The laws of aerodynamics had taken over completely, and Flight 587 was now at the mercy of forces that no human skill or technology could overcome, given the catastrophic structural damage that had occurred. As the vertical stabilizer fell away from the aircraft, tumbling through the air in its own tragic trajectory toward the ground below, it was followed seconds later by both engines. Their massive weight and the extreme aerodynamic forces generated by the aircraft's violent motions tearing them from their wing mounts in a secondary structural failure that sealed the aircraft's fate. The General Electric CF6 engines, each weighing over 9,000 pounds and representing millions of dollars of sophisticated technology, tumbled earthward separately from the main aircraft, their separation further destabilizing the aircraft and removing any remaining possibility of recovery or controlled flight. Flight 587 was now essentially a 200,000-pound projectile, falling toward the densely populated neighborhood of Bell Harbor in Queens at over 200 miles per hour, with no possibility of pilot intervention or miraculous recovery. The aircraft's final moments were captured by several witnesses on the ground who watched in horror as the Airbus fell from the sky in pieces, its destruction visible to anyone who happened to look up at that terrible moment. The impact was inevitable, and both pilots undoubtedly knew that their efforts to save their aircraft were futile. Yet they continued to fight until the very end, demonstrating the courage and professionalism that defines the best of aviation. The aircraft impacted the residential area at 9:15 a.m., just 2 minutes and 47 seconds after what had begun as a completely routine takeoff, striking the ground with tremendous force at Newport Avenue and Beach 131st Street, and instantly destroying 5 homes while damaging dozens more in the surrounding area. The massive fireball that erupted from the wreckage consumed everything in its path as 10,000 gallons of jet fuel ignited in a devastating explosion that could be seen for miles and was felt by residents throughout the area. The explosion created a mushroom cloud that rose hundreds of feet into the air, visible from Manhattan and creating panic among residents who feared another terrorist attack in the aftermath of September 11th. All 260 people aboard Flight 587 perished instantly in the impact and explosion, along with 5 people on the ground who were simply going about their daily lives when tragedy struck without warning, bringing the total death toll to 265 innocent victims who had done nothing more than board an airplane or live in their homes. The tragedy struck a community still reeling from the September 11th attacks just 2 months earlier, and initial fears of terrorism gripped the nation once again as news of another aircraft disaster spread rapidly through media outlets and social networks. However, investigators would soon determine that this was not an act of terrorism, but rather a tragic accident that exposed critical gaps in pilot training, aircraft design philosophy, and the industry's understanding of wake turbulence effects on different aircraft types. The National Transportation Safety Board launched one of the most comprehensive and detailed investigations in aviation history, examining every conceivable aspect of the accident from the initial wake turbulence encounter to the structural failure of the vertical stabilizer to the emergency response efforts that followed. The investigation would take over 2 years to complete and would involve hundreds of investigators, engineers, pilots, and other experts from around the world who worked tirelessly to understand exactly what had happened and why. Teams of investigators examined the wreckage piece by piece, reconstructing the aircraft like a 3-dimensional puzzle to understand the sequence of failures that had led to the tragedy. Investigators discovered that Captain States had applied alternating rudder inputs with a force and frequency that exceeded the design limits of the vertical stabilizer structure, creating loads that the composite tail could not withstand, despite its advanced design and construction. The Airbus A300's sensitive rudder system had amplified these inputs beyond what the pilots intended, creating a deadly feedback loop that stressed the structure beyond its breaking point. However, the investigation also revealed that States had not received adequate training on the unique characteristics of the Airbus flight control system, particularly regarding appropriate rudder usage during wake turbulence encounters and the differences between Airbus and Boeing flight control philosophies. The tragedy of Flight 587 led to significant and lasting changes throughout the aviation industry, affecting everything from pilot training programs to aircraft design standards to wake turbulence separation requirements at airports around the world. American Airlines immediately modified its training programs to better educate pilots about the proper response to wake turbulence, emphasizing that gentle, measured control inputs are often more effective than aggressive corrections that can overstress aircraft structures. The airline invested millions of dollars in new simulator programs and training materials designed to teach pilots the subtle but crucial differences between aircraft types and control system responses. Airbus redesigned the rudder control system on subsequent aircraft models to prevent excessive loads and provide better feedback to pilots about the forces they were generating, while also improving the training materials and procedures used to transition pilots from other aircraft types. The Federal Aviation Administration implemented new wake turbulence separation standards for aircraft following heavy jets like the Boeing 747, increasing the required separation times and distances to provide additional safety margins for following aircraft. The composite vertical stabilizer from Flight 587 was painstakingly reconstructed by investigators in a massive hangar, with each piece carefully catalogued and analyzed to understand the precise sequence of structural failures that led to the catastrophic separation. The investigation showed that the stabilizer had been subjected to alternating loads up to 5 times greater than its design limit, demonstrating that even the most advanced materials and sophisticated engineering have finite strength boundaries that cannot be exceeded without catastrophic consequences. The failure analysis revealed important lessons about composite material behavior under extreme cyclic loading that have been incorporated into new design standards and certification requirements for all future aircraft. For the families of the 265 victims, these technical revelations and safety improvements provided some measure of understanding, but could never fill the enormous void left by their devastating loss or ease the pain of losing loved ones in such a sudden and senseless tragedy. The Dominican community in New York was particularly hard hit, having lost so many members who were simply traveling home to see family and friends during what should have been a joyous reunion. Memorial services were held on both sides of the journey, in New York and in the Dominican Republic, as two nations mourned together and tried to make sense of a tragedy that had claimed so many innocent lives. The crash site in Bell Harbor became an impromptu place of remembrance, where residents who had lost their homes stood alongside family members who had lost their loved ones, united in grief, but also in their determination to honor the memory of those who had died. The community's response exemplified the human capacity for resilience and compassion in the face of unimaginable tragedy. As neighbors opened their homes to displaced residents, volunteers worked around the clock to provide support and comfort, and the entire area came together to heal from this sudden and devastating blow to their peaceful neighborhood. Today, more than 2 decades later, Flight 587 continues to serve as a powerful reminder that aviation safety is built upon the lessons learned from tragedy, and that every accident, no matter how devastating, can contribute to making flying safer for future generations. Every aspect of the accident, from the wake turbulence encounter to the structural failure to the emergency response, has been thoroughly studied and addressed through comprehensive regulatory changes, extensive training improvements, and significant technological advances that have made similar accidents far less likely to occur. The 265 people who died that November morning did not die in vain, if their sacrifice leads to safer skies for future generations of travelers and helps prevent similar tragedies from occurring. Modern pilots now receive extensive and sophisticated training on wake turbulence avoidance and proper control techniques, with particular emphasis on the unique characteristics of different aircraft types and the importance of measured responses to unexpected disturbances. Flight simulators now include highly realistic wake turbulence encounters that allow pilots to practice appropriate responses in a safe environment where mistakes can be learning opportunities rather than fatal errors. Aircraft manufacturers have incorporated the lessons learned from Flight 587 into new designs, creating more robust structures, more intuitive control systems, and better training materials that help prevent similar accidents while maintaining the efficiency and performance that make modern aviation possible. If this story has moved you and helped you understand the complexity and importance of aviation safety, I encourage you to like this video and subscribe to our channel for more in-depth examinations of aviation history, safety investigations, and the ongoing efforts to make flying as safe as humanly possible. Share this with others who are interested in understanding how we learn from tragedy to create a safer world for everyone who travels by air. Your engagement helps us continue telling these important stories and honoring the memory of those who were lost, while educating others about the critical importance of aviation safety and the dedicated professionals who work tirelessly to protect every passenger on every flight.